In this question, the ratio of distance traveled by a freely falling body in the first, second, third, and fourth second. So, to find this distance, we can use this formula, which indicates that time interval. So, Sn is equal to S u plus 1 by 2 a of 2t minus 1. So, for the first second, so it is S1 is equal to 1 by 2 g of 2 into 1 minus 1. U becomes 0 because it is freely falling body. So S2 is equal to 1 by 2 g of 2 into 2 minus 1, and S3 is equal to 1 by 2 g 2 into 3 because it is third second, and this is for fourth second. So if we calculate, we will get S1 is equal to 1 by 2 g, S2 is equal to 3 by 2 g, S3 is equal to 5 by 2 g, S4 is equal to 7 by 2 g. So the ratio of S1, S2, S3 and S4 becomes 1 by 2 g and 3 by 2 g, 5 by 2 g and 7 by 2 g. So the ratio between these is 1 is to 3 is to 5 is to 7. A vehicle travels half the distance with speed v and the remaining distance with 2v. Its average speed becomes, so if we want to find average speed, v average is equal to 2v1 v2 divided by v1 plus v2 is the formula. So if we substitute v1 is equal to v and v2 is equal to 2v, we will get the v average of 4 by 3v. A small block slides down on smooth inclined plane starting from rest at time t is equal to 0. Let Sn be the distance travelled by the block in the interval t is equal to n minus 1 to t is equal to n. Then the ratio Sn divided by Sn plus 1 is, so for Sn, this is u plus 1 by 2 a of 2t minus 1. For nth, for Sn, it is 1 by 2 g sin theta of 2n minus 1. Instead of t, we can take n. Okay, so instead of acceleration, we can take g sin theta because it's sliding. During the sliding, the acceleration is g sin theta because of the component of acceleration due to gravity is changed. So this is g sin theta. So Sn plus 1 is equal to 1 by 2 g sin theta. Instead of t, we can substitute n plus 1. For the ratio of Sn divided by Sn plus 1, that is 1 by 2 g sin theta of 2n minus 1 divided by 1 by 2 g sin theta 2n plus 2 minus 1. So if we cancel this, we will get 2n minus 1 divided by 2n plus 1. In this question, the position of a particle is given by r cap of t is equal to 4t I cap plus 2t square j cap plus 5k cap, where t is in seconds and r is in meter. Find the magnitude and direction of velocity at t is equal to 1 second with respect to x-axis. So v of t is equal to dr of t divided by dt. So if we differentiate with respect to t, we'll get 4i cap plus 4t j cap. So at t is equal to 1 second, the velocity becomes 4i cap plus 4j cap. So the magnitude of velocity is square root of 4 square plus 4 square. So the magnitude is 4 root of 2. So the direction is tan alpha is equal to y by x. So y is 4 and x is 4. So this is 1. So tan alpha is equal to 1. So alpha is equal to 45 degree. In this question, the displacement versus time graph is given. So the angles is 30 degree and 40 degree, 45 degree, which the x-axis as shown in the figure. The ratio of the respective velocity we need to find. V is equal to dx by dt, that is equal to tan theta. For 30 degree, it is v1 is equal to tan 30 degree. So v1 is equal to 1 by root 3. For 45 degree, it is v2 is equal to tan 45 degrees, so v2 is equal to 1. So the ratio of v1 and v2 is 1 divided by root of 3. So v1 is to be v2 is equal to 1 is to root 3. In this question, we need to find the position versus time graph for positive acceleration. For positive acceleration, dv by dt should be greater than 0. So x to be increasing with variable velocity. So x is increasing. It is not a linear, so x is increasing with variable velocity. If it is in linear, so the velocity becomes constant. Okay, so it is variable. So this graph is suitable for the positive acceleration. In this question, a horizontal bridge is still across river. A student standing on the bridge throws a small ball vertically upward with a velocity 4 meters second inverse. The ball strikes the water surface after 4 seconds. The height of the bridge above water surface is. So here it is the height of bridge and the ball is thrown, so it covers a distance of h. So here we need to find the ball strikes the water surface after 4 seconds. Okay, so the height of the bridge above water surface. So here it is water, this one is the height of bridge. To find the height of the bridge, we can use the kinematic second equation, s is equal to ut plus of at square. So the initial velocity is 4 meter second inverse, so it is thrown upward. We can take it as negative sign. So g is 10 meter second per minus 2, because if we take the displacement, this is in the this covers by a dropping, so the acceleration is positive. So t is equal to 4 second. So s is equal to ut plus half at square. So u is minus 4 and t is 4 plus 1 by 2 into 10 into t square is 16. So h is equal to 64 meter. In this question, a car starts from rest and accelerates at 5 meters second per minus 2 at t is equal to 4 second. A ball is dropped out of a window by a person sitting in the car. What is the velocity and acceleration of the ball at t is equal to 6 second? Velocity of car at t is equal to 4 second is v is equal to u plus at. So v is equal to 0 because it is starts from rest, and acceleration is 5 and time is t 4 seconds. So v is equal to 20 meters second per minus 1. After 2 seconds, the ball is dropped. So horizontal velocity of ball vx is equal to u plus a ux plus at. So here ax is 0. So vx is equal to ux. So Vx is equal to 20 meters second per minus 1, because this velocity is becomes the initial velocity of that one. So the vertical velocity of bar Vy is equal to Uy plus Ay into t. So Uy is 0 because it's dropped at the initial velocity of the y component is 0 because it's dropped, and Ay is equal to g. So if we substitute uy is equal to 0 and Ay is equal to g, we will get Vy is equal to g into t, Vy is equal to 10 into 2, Vy is equal to 20 meters second inverse. So magnitude is V is equal to square root of Vx square plus Vy square. So V is equal to 20 into root 2 meters second inverse. In this question, the x equation is given, which represents the position. We need to find the ratio of initial velocity to its initial acceleration. So x is equal to alpha t power 4 plus beta t square plus gamma t plus delta. If we differentiate x with respect to t, we will get the velocity. At initial time, the initial velocity is becomes gamma if we substitute t is equal to 0. If we differentiate v with respect to t, we will get the acceleration that is equal to 2 alpha t cube plus 2 beta. So dv by dt at t is equal to 0, it becomes 2 beta. So ratio of initial velocity to initial acceleration is equal to gamma divided by 2 beta. A ball is thrown vertically downward with a velocity 20 meters second inverse from the top of a tower. It hits the ground after some time with a velocity 80 meters second inverse. The height of the tower we need to calculate. So u and v are u and v, and the acceleration due to gravity relates, and it helps to find out the height through the kinematic third equation. V square minus u square is equal to 2as. So v is 80 and u is 20. If you substitute, you will get the actual value of 60 meter. A bullet from a gun is fired on a rectangular wooden block with velocity u. When bullet travels 24 centimeter through the block along its length horizontally, velocity of bullet becomes u by 3. Okay, here it is u by 3. Then it further penetrates into the block in the same direction before coming to rest exactly at the other end of the block. The total length of the block is we need to find. Between 1 and 2, the case 1 and 2, the velocity, initial velocity is u, and final velocity is u by 3, and the displacement is 24. Okay, so here v square minus u square is equal to 2as. It relates the final velocity and initial velocity and the displacement. From this we can calculate the acceleration. So the acceleration is negative because it's retarding while passed through this block, so it is negative. So the u square by 9 is equal to 48 by 8a, so u square by 9 is equal to 6a. Okay, between 2 to 3, the velocity, final velocity is 0, initial velocity is u by 3, and it's retard, so it is in negative direction, so negative sign, so minus 2as. Okay, so the s is displacement which we need to find. We don't know that what is the displacement between 2 and 3. So here this is u square by 9, this is equal to 2as, and u square by 9 is 6a. If you substitute here 6a, so the s value is 3 centimeter. Okay, so from here to here it is 3 centimeter. So totally the black length is 24 centimeter plus 3 centimeter, so it is 27 centimeter. In this question, the velocity v versus time plot of the motion of a body is shown below. So the acceleration a versus t time graph we need to find. For this graph, from this to this, the velocity is linear. So v is equal to mx plus c. If we differentiate with respect to t, we will get the constant value. So the acceleration becomes constant in this. So here the velocity is constant. So the acceleration becomes 0 wherever the velocity is constant. So here it is decreasing. So the acceleration is negative with the constant value.